Okay. So today we want to learn about functions. And then in learning functions, we will be able to also understand the meaning of the word decomposition as used in programming, the word abstraction as used in programming or object-oriented programming. So we will be able to understand decomposition and also abstraction, and then we will go ahead and understand functions. Okay. So how do we write code? So far, we have covered language mechanisms. We have known how to write different files for each computation. Each file is some piece of code. Each code is a sequence of instructions. For those who have joined before, I'll always type just on my screen. So for example, we did something like print, and then we said, hello. And when we ran, it printed for us, hello. We have also done some different calculations to do with maths. We have also done some loops where we have made our program to repeat some piece of code several times. We have also done some branching where a program has to decide which direction to take depending on a condition, so that when the condition is true, it runs on a different code. And when the condition is false, it also runs a different code. And we have seen how these are done. And so far we have seen the way this code is done in a sequence of instructions. The problem with the approach that we have used is that it is very easy for small scale problems like the problems we have been tackling. We've just been doing very, very small scale problems, maybe trying to grade students to understand whether if I enter this marks, the student will either get a B, an A, a C, a D, or an E, or then the program will just tell me that my marks is out of range. So those are very, very small scale problems. When we do that kind of mechanism with a very large problem, it becomes very messy, especially if you're to do a project and then your program will not have functions. It will just be those piece of code, those piece of files. Then it becomes very messy because you will have to repeat so many things so many times. That kind of programming approach also gives us very hard time in keeping track of details because the repetition is so much. We have to keep repeating because every code is evaluated as just itself. How do you know the right information is supplied to the right part of code also becomes very difficult. So that's something that we must have in our mind, that if we work with code and we are not making it in a functional manner, then that will be a problem. So a good programming style requires us to have more code, not necessarily a good thing. If we are having more code, so much of it, then that is not a good thing. We need to measure, the way we measure good programmers is by the amount of functionalities that they introduce. So if you want to be a good programmer, then your program must have a lot of functionalities. So we will be checking, like, if you have so much code, then your work becomes very complicated and very difficult to follow, and therefore you are not a good programmer. For you to be a good programmer, you need to introduce functions, and then you need to achieve what we are calling decomposition and abstraction. So we need to understand what is decomposition and what is abstraction as they are used in programming. So I am giving a very basic example, something I know that we all know. We all know what a projector is. We have used a projector in one way or another. A projector is just a black box. It can be white, it can be any color, but then I'm saying a projector is a black box. You don't know how it works. What you know is the interface. So you see the port where you need to put in your input and then your output. So you know how to connect maybe your laptop to it, and then now you see the way it will be able to produce the output. So you connect any electronics to it that can communicate with that input. The black box somehow converts image from input source to a wall, and then it magnifies it to be big. You really don't know how these things happen. What you see is that once you plug in the input, then you are able to see a magnified image on the wall. But the idea is you really do not understand what goes on in the background. And that is an idea of abstraction. Abstraction is like you're trying to hide a lot of things from the user, and you're only giving the user what the user needs to know. So you're doing what we call abstraction. Then how does that, now let's see about decomposition. Still with the use of a projector, projecting a large image for Olympics decomposed into separate tasks for separate projectors. So you have several projectors put in different places, and each projector takes input and produces a separate output. All projectors work together to produce a large image. So that's now decomposition. The idea is different devices work together to achieve an end goal. So when we are working with functions, we are trying to achieve decomposition, we are trying to achieve abstraction. First, we are hiding a lot of information that are unnecessary. It's like we are putting a code, and we are telling this code that this is how you will always work when you are called. So whenever we call that piece of code, it does everything that it was instructed that it will be doing. But the person using it doesn't know what it was instructed to do. You only know that when you call it, it will do 1, 2, 3, but you really do not know a number of things that are hidden. So it is abstraction and then decomposition. So apply these ideas to programming. Decomposition, break problem into different self-contained pieces. It is like the way several projectors are taking images and then pulling it to be one large image. So you break problem into different self-contained pieces. Then abstraction, you suppress details of method to compute something from use of that computation, so that the details are hidden, they're suppressed. Create structure with decomposition. In example, separate devices. In programming, we divide code into modules. We call it modules. So modules are self-contained, used to break up code, intended to be reusable. Then keep code organized, then keep code coherent. In this lecture, we are going to achieve decomposition with functions. But later on, we will be achieving decomposition with what we call classes, because Python is an object-oriented programming language, and therefore it will be using classes. So we will see how we achieve decomposition with functions, and then we will also see how we achieve decomposition with classes later on when we start introducing classes. So abstraction, we have said, is to suppress the details. Example, no need to know how to build a projector. Of course, we don't even care how it was built. The thing is, we just go and buy and we check that we want a projector that will be able to do this, 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 this. Whatever is inside that box, we don't know, we don't care. And we don't even want to know. We want the projector to project. In programming, think of a piece of code as a black box or a projector. You cannot see the details. You do not need to see the details. You don't want to see the details. You hide tedious coding details. So your idea is just to hide those serious coding details. If we were told that for us to use the projector, then we really have to understand the mechanics that is behind it, then everybody will be like, let it be, I don't want. So that's how then abstraction needs to help us, so that we don't care about the details, we don't want to know, we just want to use it. Achieve abstraction with function specifications or docstring, and I will explain what docstring mean just in a few. So decomposition, when we put it together with abstraction, it becomes very powerful. Again, code can be used many times, but only has to be debugged once. If I have a program, if I have a program and I am working on that program, and then I have so much code that is so much disunited, then if I am to debug, I will be debugging every code. But if I pull it all together and I give it one name and explain how it works, then I'll just debug once, because I'll know that I need to go to this function, change the way it works because it is not giving me what I want. And once I change it, it will apply to all parts of the program where it was invoked. Okay, so now functions, they help us to write reusable piece or chunks of code called functions. Sorry, 1 minute, let me address something. Sorry, my phone was ringing and my child does it, so he was bringing it. So it helps to write reusable piece or chunk of code that we are now calling functions. Functions are not run in a program until they are called or invoked. So we are going to also see that. Function characteristics are like, what do we need when we are using a function? A function must have these things that I'm going to mention. First, function has to have a name. Because when you're calling something, you need to call you need to call it with its name. If I say Lucy, I know I am calling Lucy and I am not calling Ramadan. If I call Rolex, I know I'm not calling Rashid. So a function must have a name. When you're naming your function, especially if it is user-defined function, then you remember the rules of naming your identifiers or the rules of naming your variables, as we explained. It must not be a keyword, must start with alphabetical letter or an underscore, but can combine alphabetical letters, underscore, and numbers. Must not have special characters apart from underscore. And then always remember, it must be a relevant name. You need to give it a relevant name so that you don't call your function function X. If, for example, you're writing a function that will help you to square numbers, then you can even call it square numbers instead of calling it function A, because then tomorrow you will even forget, what did I say? What was function A supposed to do? And then the other person that will be using it will be even more confused, because even you have forgotten what A was supposed to do. So it has to have a name that is relevant and obeys all the rules of naming your variables or identifiers. Then it can have parameters. So we are saying parameters can be 0 or more. In a few, we will know what parameter is, and even why it needs to have 0 or more. Then it should, we are saying this is optional, but very recommended, that it has a docstring. A docstring is just a small string that explains what your function is doing and the way we are required to use your function, so that when I question your function, I will be able to know how your function is working and the way I need to use it and what exactly it is doing when I call it. Then the function has a body. So it has 0 or more parameters. That means there must be that bracket, the bracket, this. So whether nothing goes inside it, those brackets, the opening and closing bracket, must always be there to show that it is either a 0 or more parameters. Then a docstring, and then the body. So it must have its body. And when we were doing the control structures, the branching and loops, we talked of what a body is. So we need to know what is a body, but then we are saying a function must have a body. How to write and call or invoke a function. So I would call this syntax, even as I explain it. So the syntax of a function. First, when you are writing a function, you need to have this keyword def. That keyword def for define function. So you don't say define, you say def. That keyword must always be there. Then you need to give your function a function name. Mine, I have called kindly mute when you're joining. You need to have the keyword def. So this remains def as a keyword. All the time when you're defining your function, you start with that keyword def. Then the next thing you do is that you give it a name. So the name of the function can be anything. I called mine is even because I wanted to just print for me the even numbers. So I called it is even. You can give it any name. Then you see the bracket. So that means, let me write somewhere here. I hope you will be able to see my screen as I type. So that means I say def, and then I give a space and do the function name, and then I do that. So inside this bracket is where my parameters go. So in this case, my parameter is 1, I. After that, you put a full colon. You put a full colon. Once you put a full colon, of course, Python requires that the body of any function goes 4 steps, indentation of 4 steps. So 1, 2, 3, 4. If you are using an IDE, it will be able to indent it there for you. So you can put a doc string. For you to put a doc string, you put a string with those 3 quotation marks, because it is now a block of quotes. I've been just putting a comment of this, the one I've been using to do my comments since we started learning, and that is because I was just putting a one line comment. But because now my doc string is going to be like a block of comment, then you put that, it shows that it is a doc string. There are 3, and then again you put the 3, and your doc string goes inside here. So this is where you explain what we need to do with your function. So for example, mine says input I. Input I is needed, a positive integer, returns true if I is even, otherwise false. So this is exactly what my function will be doing. So the user will know that he is required to input a positive integer. And when the integer that you have put is even, then it will return true. Then the other part of the function is the body. Now what it does. So print hi, then return I modulus 2 equals 0. So that means if I divided by 2 and the remainder is 0, then you return true. So then that is when it is an even number. So later in the code, you can call the function using its name and the values for parameters. So later in the code, so my function begins from here where I have circled with green. It begins and it ends here. So this is not part of the function. My function ends with the word return. So when I say return, then my function ends. So it ends there. Then this is how now I will invoke it, or I will call it later in the program. I can invoke it by saying is even. So is even is the name. So when I say is even and then I put in bracket 3, then 3 is the I. 3 is the I. So then remember, I was told that if I input a positive integer, it will return true if the positive integer is an even number. So of course, this will return false. So basically, that's the way the function looks, the body and the way we invoke it later on in our program. In the function body, remember we have said def is even, and then I have given a small doc string, print hi, return I %2 or I modulus 2 equals 0, evaluate some expression. Then return is also a keyword. Then expression to evaluate and return. So that means that every moment somebody enters an integer value, then that integer value will be evaluated and that will be returned. And then about function call, of course, I've explained it, but I'll just do it again, is even. So because my function was called is even, the moment I call it, I'll just call it with its name, and then I put the parameters as was required. I'm required to put only one parameter. So if I have 3 and maybe another number, it will not work. So I need to have 3, 4, 5, as long as it is a positive integer, it will work. Again, just that is the way it will work. One warning is that if there is no return statement, then Python will return a value none. So for example, if I was to run this program, then this program will just give me the word none, because it is not supposed to return anything. Remember, here we have return. Here we don't have return. So if I run this program, it will just tell me none, because I did not tell it to return anything. So none is not an error. None only shows the absence of a value to be returned. There is a difference between return and print. Okay, I'm taking some questions. Somebody saying kindly, so that's another way of commenting in Python, yes. And then kindly, is the green part of code or just a comment? Okay, let me move back to see that green part you're talking about. Sorry. Aha. Are you talking about this green part? Okay, yes. Because this is a comment. You see, if I say def is written in blue. If I say return, if I say return is written in blue, def is written in blue, print is written in is that purple? And then this part is written in green. A comment is normally written in green. So it is, when I do it like this with the 3 quotation marks inside a function, the interpreter understands it as a doc string. It is not supposed to be evaluated. It is just a comment. So comments appear in green. Whether I put a hash, it will just appear in green because it is just a comment. So I don't know whether that answers you. Thank you. So let's see the difference between return versus print. Return only has a meaning inside a function. So you can't write return if it is not inside a function. It will not have a meaning. Print can be used outside functions or inside functions. So inside function as a part of code that will display when that function is called, and then outside function to do the normal print the way we learned it. Then in return only returns one value. So only one return executed inside a function. But print can execute many print statements inside a function. Return, code inside function, but after return statement, not executed. Print, code inside function, but can also be executed after the print statement. Again, we are saying return has a value associated with it. given to function caller. So every time we are writing our function, we know that this function, we are writing it so that it helps us to do this, this, and this. So later in the program body, when we call that function, we call it and it will give us, it will return the statement that was under return. So that's how return works. It is given to the function caller. A print has a value associated with it. So it is outputted in the console, and we had learned about print. So I'm just giving the difference between print and return so that we don't think that they are doing the same thing. Return only has a meaning inside the function. So up to that point, I want to get my Jupyter notebook so that I work with it in the IDE where I am able to maybe run it, and so that we see what really happens. Basically, I have explained why we need the functions, why they are necessary. And then you can remember that even in mathematics, we normally have functions. And what the functions do in maths is that we assign some things to the function. And then when we execute those functions, we get the results. So not to bother you with so many mathematical explanations, that will be okay. Then function in programming, we have said that it helps us to structure the program. It helps our program to be more readable. I was muting somebody. It helps our program to be more readable, because then the program will not be so much. If we divide them, if we decompose them in small functions, then the program will not be too complex. So our program becomes more readable. Then also it enables reusability, so that a piece of code can be used and reused and reused several times. Consider this small program. So if I say name equals, and then I put them in this kind of, these are called square brackets, then I'm defining a structure called list. We have not done data structures. And of course, after we learn about functions, we'll be going to handle the data structures. We will be talking about list, tuples, dictionaries, set, and the rest. So if I say name equals, then I give it 3 names in a list, like Christian, Stefan, and Lucas. Then I say for name in names, print hello name. So if I run this code, in this program, the print function is a predefined function in Python. The print is a function that already is in the dictionary, in the library of Python. Python interpreter understands it. So if I say print and then I say hello name, and because this was a loop, it will be looping from the first name, Christian, then goes again to say hello Stefan, then goes again to say hello Lucas, because it will be looping over it. And then print knows what print should be able to do. So much so that it knows that when I say print and then whatever is inside the bracket, whatever is in the bracket needs to be printed out on the screen. And I think we talked so much about print function when we were starting. But basically, I am trying to say that print is a function. It has it has a predefined meaning. Python interpreter knows what to do with it. And every time we invoke it or we call it or we use it, then it is working the way it needs to work. So in this program, function, a predefined function in Python, print is a print function, a predefined function in Python is used to create some output. Kindly mute. Using the print function, it has several advantages. One, the print function is reusable. We already used it in several programs. Every time we just say print and it prints. We just say print and it prints. So we have used it several times. We have told it to print several different things and it has been doing it. But then it was defined once. But then it is abstracted from us. We don't even know what is inside it. Of course, we will be able to check and see, but we don't care. What we know is that when we are using it, whatever we quote appears the way it is. Whatever we don't quote appears differently. And then there is error if you don't use it the way it needs to be used. The print function makes the program more readable, as in it gives a name to some functionality, print in this case. So there is a name, print. Because the details of the implementation of the functionalities are hidden, and that is now the abstraction part of it. The content of this week focuses on writing functions in Python and using them to structure programs. So basically that is what we are doing. So as already again mentioned in the previous session, we have already used some functions like print to print the document on console or on the screen. We've used int for data casting. I remember when we were working with input function, we casted it using int so that the data that was going inside it would come out as integer. And that we have done several times. Of course, in programming languages, it is also possible to define your own functions. So you come up with your very own functions. And then now when you're coming up with your own functions, that is when you do what we were saying, def, double. So I am calling this function double. Def is a keyword, then double is now the name that I'm giving it. And then X is the parameter that is going inside there. Then I'm saying in a docstring that my function double doubles the value X. So that means if I give it a value, it doubles it, it multiplies it by 2. So what my function does is it returns X times 2. And then this is a full function. If you execute the above cell, it seems as if nothing would happen. Actually, the cell is only defining the function, but is not executing yet. So there is nothing going on. I'm just defining the function. Nothing is going on. So if I run this code, nothing happens. But then it is now known. The function double is now already known. It is captured. So in this other cell, we are now going to call. We want to see the way now we are going to use our function. Remember, the way we are using print is that we call it and we put documents inside it. And now I can now use my double. So in using my double function, I say letter D equals, okay, assign. Remember, this is an assignment symbol. A double 21 is assigned to D. So that means when I print D, I will be able to print 21 times 2, because my function doubles every number that is given. It doubles anything that it is given. So if I say double 21, then it means I will take this 21, multiply it by 2, and do whatever I am told to do with it. So once I take 21, multiply it by 2, then I print the result. So I'm expecting that if I run this, it will be 21 times 2. I can also say print double hello. Remember, I gave you an assignment to see how the multiplication operator is being overloaded. Like we talked of operator overloading. We saw the way we can use addition to concatenate a string. When you use multiplication, it doubles, it repeats that word the number of times that you want it to. So if I say hello, but then I am calling the function double on it, then it means it will be multiplying hello. So it will give me hello, hello. So if I run this code now, then I will get 42 for this print. I will get 42 for the first print, and I will get hello, hello for the second print. Why? Because I am using my function double, and I had told my program what to do with my function double. So that's how it is being invoked. That is how it is being called. We call it function calling or invoking a function. Function in Python are defined using the syntax, and I think I had explained that. The keyword def followed by a function name. The function name can be used to call the function. So, and then we have the docstring, and I've explained what the docstring does. So let's again see about this. The cell below contains a Python program consisting of several parts. First, a function greet is defined. So I am first of all defining a new function called greet. Next, this function is called 2 times with different parameters. So I have different parameters, but I am trying to reuse, to show the reusability of this function greet. So the definition starts and ends here. The definition of this function starts and ends here. So def, greet, name. So there is one parameter, name, and then of course full colon and then an indentation. So return, so every time we call this greet function, it will return this word, may the force be with you, plus the name. So the name is the parameter that you will feed it with. So it will be, may the force be with you, the name that you give it, plus that name. So I'm defining a value n. This is just a variable. I'm calling it look. Then I'm also saying greeting is equals greet n. So I am saying greet look. So I'm expecting that if I am calling greet look, then I should be having may the force be with you look. If I print greeting. So see the way this part is done. First, assigning a string value to this variable, then giving a new variable to keep for me that value in the grid plus look, then print it out. Another way of doing it is just to say print, then I invoke grid, then I give it the parameter name. So maybe you look at it and you see how it looks. One more time. For look, I define it this way, and this is where I call it. But then I can just call it direct the way we have been saying, int, input, and then we put a value. Let me check if I have a question. A docstring is a docstring. A docstring is like a comment within a function, so that when I define that comment in a function, it explains what that function does. Of course, if I want to have a block of a comment, like a multi-line comment in any other part of code, then I can use the double quotes 3 times and it will block for me several blocks of code. But when I put it inside a function, then the interpreter will understand it as a docstring. Like, so that I'll show you how now it will happen if you're working with it, just in a few. So I know I have it somewhere where we are going to see why we call it a docstring when we are using it inside a function. Then you will be able to see it maybe practically. So I was explaining that to the person who asked that question. And then I'm saying we can call it this way. We can also use this other method to call it. So now if I run this code, then I will have, may the force be with you, Luke. So remember that. Then again, I'll have, may the force be with you, Christian. So basically, I have explained that the definition has no output. Then the function greet is called twice with the different parameters. So the first parameter is Luke, and then the second parameter is Christian. So if once I share, if you read this, it will explain it more. But the first, the variable n is set to the value Luke. Then the function greet is called and the variable n is passed as a parameter. By calling the function, the value of the variable n is assigned to the parameter name. So that's by calling that function name and putting them together, then that is what is happening. So then you remember that if you call that function greet, then it will come with so many things. It will come with may the force be with you, plus the parameter that you will give it, so that it is may the force be with you, Luke. May the force be with you, Christian. What so this for the person who really wanted to know about docstring. As already mentioned above, one reason to use functions is reusability, so that you can use it and use it and reuse it and reuse it. Certain functions is required, certain functionality is required again and again. It makes sense to provide this functionality once, so that not every programmer has to implement it again and again. If a function is provided, then it is necessary to give information. What this function is all about, how to use this function, to keep this explanation together with the actual implementation, then that is when we use the docstring. To access this explanation, simply type the name of the function followed by a question mark into a cell and execute it. So if I run this, I had my double. So if I run this, sorry, if I run this cell, then it will give me this information. double, it doubles the value X. It is of type function, and it gives me all that. If maybe I have a print and then I put a question mark and run it, then I get this explanation. Print the value, then you have some string, you can, and then the whatever is separating those string are a space, and the end is /n, and all that. Print the value to a stream or to system.standard out by default. So it gives you exactly, you see, and you can do it to any other function. Input, and then you do that, and then you run it. So when you run it, it even explains to you how it is used. So when I gave the double one because the double one is the one that we did ourselves. And so you see, it captures it as a doc string. It captures it as an explanation within a function. Thank you, Rolex. So it gives that explanation. So maybe you can try and do with the question mark and see the way others work, but then now you get to know the difference between now a doc string. When it goes inside a function, the interpreter will give it out to help the user to be able to use it to analyze or to understand how that function works, what that function is doing, and all that. So let's see about returning results from functions. In the previous example, we have already showed that functions have an optional return value. The return value of a function is defined by the word return. So it's a keyword, and therefore you cannot use it the way you want or however you want. It's a keyword, meaning it has its meaning defined within the library of Python. A function in Python only has one return value. If you want to return multiple values, they will be packed as one tuple. And maybe we are going to learn tuple in the future. And then once we learn tuple, you will see the way it is working. And this will be the one return value of the function. So there is no way you're going to have several return values. The body of a function ends at the moment that you say return. So immediately you say return, it will not capture any other thing that you write after it. It is not part of it. So the moment you say return, boom, it is case closed. The following cell shows an example of a function without a return value. The function simply prints a result. The return value is empty. This is shown using the special value none. So if I run this, remember my function is up here. So I have def, print greeting, print, no, I am your father. There is no return value. So then I am defining a variable called empty return value. Then it prints for me the greeting, then print empty return value. So let's see what happens if I run it. If I run it, it prints for me, I am your father, but then it gives me this word none, meaning there was nothing that was returned. It was none. And as you're going to work with functions, I know most of the time you will be wondering, why is my program running, but I'm not seeing the result? I am just seeing the word none. Why is this word none coming? And remember, we said none is not an error. It simply means your program is not returning anything. The following cell shows a similar function to the previous. In this case, the function returns the value. So now if I run it, remember the other time I said print, but right now I'm saying return. And then I'm doing everything else the same way. So if I run it, then I'm having no, I am your father, and there is no word none. Of course, it is also possible to return other data types from the function. So looking at this, I can say def, the answer to everything, and then return 42. Return 42. So this is where my function ends, return 42. So print, what is the answer to life, the universe, and everything? Then I am calling the answer to everything, and then I am closing. So when I run it, it will give me what is the answer to life, the universe, and everything, 42. Again, another one, just to have us do a number of it before I give you one to try yourself. Def, is Python the best programming language? Return true. So if is Python the best programming is true, then you will print this. This is a picture of Python that I've given inside. There's a string, so it prints it. And then I also have another list. Remember, I said that we will learn about lists, but so far what you need to know is that if I put the square brackets and put things inside the square bracket, then I'm defining a list. Of course, we will learn that. So if I have a function called Ramon's records, and then it returns Ramon's, leave home, rocket to Russia, road to Rio. For record in Ramon's records, so that's a loop, a for loop. For record in Ramon's record, so that means it is moving from Ramon's to leave home. So it is looping like that up to the road to Rio. Print, I am listening to record. So I am listening to the whatever I am looping through. So that if I run this, I get I am listening to Ramon's, I am listening to Leave Home, I am listening to Rocket to Russia, I am listening to Road to Rayon. Again, we have said that the body of a function ends at the word return. So anything you do after the word return is never captured. It is not known. It is not part of that function. Whether it is syntactically correct or not, it is not considered as part of that function. So if I have a function famous quote, return, no, I am your father, then I say print, this is not executed. If I run this after calling this function, you will realize that it will only print, no, I'm your father, but it will not print this print. In as much as we know that whenever we use print, whatever inside it is printed on the screen, in this case, it is not even seen. It is not even considered because my function ended immediately I said return. So this is like null and void, like a waste of time. It will not work. So if I run this, I needed to ask you what happens when I run that. So if I run that, then I have def and then F3, print 1, return 2, print 3. So then it will print for me that. Okay, up to there, I want to give us a little exercise so that before I move to the next, I know that we are together. So maybe I just want you to define a function that can help us to square a number. So let me type my question. Define function that gets an integer value as a parameter and returns its square. So of course we know if we enter a value like 4, then if we feed it with a value like 4, then it should give us 16. So it needs to double it, like square it. Is squaring doubling? Okay. Doubling is like multiplying by 2, but we need that it is squared, it is multiplied by itself. So we can try that. I give us like 3 minutes. Will that be okay? You can type your work on the chat so that we just copy it, paste it, and run it. Or someone can share his screen or her screen, and then we see how you have done it. Are we here? Hello? Hello?
Hello.
Yes, Rolex, we are in. Oh yeah, so that's the a short assignment. Just try and pull it up, and then I see how it works. I can pause our recording and then continue. Okay, so I'll look for a space, and then I will paste it. So let me add. I paste it. So let me run it. You said I just ran it? I have a invalid syntax where?
The return using small r.
Where? Oh, you know you are the one going to guide us. So I've changed that. Can I run it again? Still there is a problem? Or is it because you're using capital D also?
Yes.
Okay, let me run it again. Aha, it is telling us that num square is 6. Is that true? Is that true?
Or maybe you could write there return num times num. Or?
Num times num. Okay. So let me run it. 16. Let us try another one so that we are sure. 25. Okay.
Or maybe
so let us try 10. So then we are sure. Why do you think?
Or maybe you could put num, then multiply 2 to mean exponential.
Okay, okay. So let's do it again. But that one worked, right?
Yeah, yeah.
Okay, so 10, 100, you're 4, 16. So that also works. So the idea is that originally you used a wrong operator. So in Python, that is not exponential. You need to check, why did it give us 6? If it gave us 6, then what is that operator in Python? We learned about Python operators and we had done that. So go check our notes and also understand what does that do? Because in C, C++, in Java, and several of them, this one here is an exponential. It does what this is doing, right? Yeah. Any other person who has a work? Okay, let me copy yours. This is Samuel. I'll paste it. Haha. Samuel, remember you are the one going to guide us. Do I run it like this? Samuel, I'm waiting. Okay. He's saying that we help. So somebody can help. Who is gonna help? Do I just pick randomly? Or Captain, you want to help?
Can I?
Okay, good. Rolex, go ahead.
So the returns will be on the second line with a space equivalent to tab or 4 spaces.
So I do that.
Yep. Then the
And then
print should also be
down there.
Yeah.
I run it.
Will not.
No. The print should come before the
What do I do?
put the
Closings.
print before the return.
I put the print before the return.
Yes.
Okay, I just carried all of it.
Mm-hmm.
Okay, it is Control X. Okay, Control V, I run.
And then you see now he has created a square variable.
Mm-hmm.
So that square variable,
Mm-hmm.
I think we should declare it.
Where?
Just right on top of the print, say square is equals to, and then you do n squared.
Up here.
Yes, just yes there.
Oh, are you really not complicating it?
I'm just doing according to how he has done it. Because he's using the print.
Oh, okay. So what are you saying I do? I say square
Square is equals to
is equals to,
n times n.
and what about the return n times n exponential 2?
So you said
Because
it will,
then I'll be having,
it will do both the
Mhm.
it will do both
Mhm.
it will do both the print and the return. But now after at the return here, you can just say return square.
Okay, let's do yours and see what happens. So here I say return square. I don't want to rub his, so I'll just comment is if you allow me. Then I'll have yours. Here, just here.
Yes.
Return, you saying I say square.
Yes.
Then I run it.
Yes.
Okay, there is an error still. Actually, the
Okay.
error is
Yeah,
saying,
closing.
Oh,
Here the square.
this is the square. Close the quotation.
Yeah,
Here.
quotation. No.
here,
No,
here,
there.
here.
Yes. No,
Where?
no.
After the comma.
After the comma. So I remove it. I put it here.
Yes.
I
One
know you
comma.
will say just one. Okay.
Okay, print. Run it.
I did. There is no result.
There is no return.
Yeah, I actually ran it. I can run it again. I'm very loyal. I did. Actually, I can run
No,
it.
I know what we now. Let us now call the function.
We call the function, okay?
Yes.
So
Square, and then we give it a value.
square
Square into brackets, let's say 5.
5. I am running it. You're seeing that? Or am I the only one seeing this? It has even gotten annoyed. Can only concatenate string, not integer.
Okay, I see. So now the square in the print, make it a what is it called?
I
Let
make
us
it a string.
Yes.
I will do that. I will always do that. That way?
Yeah, and close the outer bracket.
I thought I had closed it. Okay. That way?
Okay, let's run it.
Okay. This is the square 25, and then there is another 25. So it is doing it twice. So it is doing it twice. It is doing
debug code.
Hello?
He said he wanted to be helped to be able to debug his code so that it can run.
Yeah, but you see, we are having 2 results and we only need 1.
We can remove the print.
This one.
The whole of.
But he wants that statement. I believe Samuel wants that statement, because if I remove, then I have 25. Then that means I can also remove this. No, I can't remove that. Okay, so if I wanted to help him, I would have his code the way it was. I'll mute yours, then return his. So I'm just muting yours. I hope Samuel is seeing. This was his, right?
Yes.
So I'll have this. Out of there. So I will return. I'm thinking of putting it here. Print. This is the square. And then
you said nothing can come after the return statement.
Yeah, but it is not part of the body. See this one.
Okay.
What is this?
Okay.
This is no longer it. The function ends here, right?
Yes.
Just like his. Whose was this? This was for Rolex. And even mine, you see? That was Tony's. Okay, that was Tony's. So we agree that the body is only part of the indentation, whatever has been indented, right?
Yes.
So that if I indent this and this, then these two are part of this function. This is part of this function. But this is indented, but it is not part of this function because it is coming after the word return, right?
Yes.
Yes. I love the way you're putting yes. So that means this was Tony's program. The function ended here. This was not part of the function. This was the function call. So instead of having all these inside the function, why don't we have it as a function call? Is that okay?
Yes.
Yes. Let me see if it works.
We have
I hope
now.
I hope there is something missing here.
Okay.
Somebody talking?
No, let's just run it.
Let's just run it, we see. I have a problem. Oh, there are three.
Yes.
1, 2, 3. Yeah. So boom, it works. So I know Samuel wanted these words. This is the square. Those are the words that he wanted. So Samuel, this is how we do it. Of course, I'm now allowed to delete this. Of course, the definition of your function ends here. The definition of your function ends here. You just need your function to be able to return the square of any number that you will give it, right? So when you go to the body, then now you will be calling it. So this is where we call. I'm trying to put my arrow here. So this is where we call it. We are calling the square. And we know the moment we call the square will multiply the n. So the n is the parameter that will go inside here. So if we call square, it will multiply this n. But all these other things are just the print. They are not part of our function. They're just the print function. And then you remember the print also have a doc string, the way it needs to be used. So that means if we say this is the square, then we need to return to cast this value 25 to be a string, because then there is no way we are going to add this value here. This is square plus 25, and 25 is an integer. It is like we said before, we said that I cannot add Samuel. Samuel, I'm used to writing your name like this. Don't worry, I saw you write it differently, but it's okay. If the moment I add that, I can never get any value. There will be no value. So for me to add Samuel and number 4, then I need to make number 4 to be a string. So when number 4 is now a string, then I can add it, and then I will now get Samuel 4, right? So that's what we are basically doing here. We have this is the square and it is a string, and we want to concat it so that we have 25 and maybe 4, or maybe whatever we want to concat, so, which we are calling operator overloading. We are making addition to do more than it should be able to do, because in maths, we know that addition is just to add numbers. So when we are adding string, then we are making it to add objects, and it is doing more than it should. And so then we are saying we are doing operator overloading.
Is there another way to do the print without using the screen?
Oh, okay, let's think about it. What if, let me try if it will work. What if I put a comma here so that I don't concat? It works.
Yes. Okay.
You see, I can concat or I can just separate. So maybe after this, you can just Google several ways of using. Tony, you know, I muted you. I know you're not happy about it, but I had to do it just to remind you that we are recording and you need to mute. So if I put a comma, I am not concatenating, but if I put a plus, then a plus is concatenating. But basically, you need to zoea. You need to love doing it. What's so difficult? I just put as a T and a plus, and it is okay. So if you don't want that, you just put this, and it will still work. It worked. Any other person that we are 12. So any other person? Any other person? Oh, Rolex, this is yours. Let me see Rolex. Okay. Oh, sorry, it jumped that far. Okay, so we are running it and we will help Rolex to know where the problem is. I'm seeing, oh, somebody. Can you touch on F string? Oh. Okay, but maybe not now. And then if our user needs to input another value of n, where in the code will he or she input it? Okay. So of course, I'm answering all that, but of course, Rolex, you know your issue now, right? Rolex, if I run your code, what will happen?
It will run, but it will return a value now. Is it?
It will?
Return a value now. Is it?
I'm just hearing it will return a value, but I am, or you're saying it will return a value none? No. You know you are returning, so there is no way none can come. We return a value none if there is no value to be returned. But you are returning integer multiply exponential 2. So it can't have 2. It can't have none as a result. What do you think if I run your code will do?
But I've not assigned integer to any number. Maybe you can try.
No, I want you to understand these functions. Like, even if you wake up at in the middle of the night, you look at this code and you know this is where my problem is. So look at this was Tony's work, then this is Samuel's work that we have all worked on. So look at the two. What do you think your code is lacking?
The print.
But Tony has no print.
Oh.
Tony has no print, but if I run Tony's work, I get results. I can actually put 3. And if I run, I get result. He has no print. So what do you think yours is lacking?
The calling. Is it?
Yes. I hope somebody has not told you. Oh, Samuel, you're cheating in exams. Eh? Samuel has showed you, your function is okay, but there is no calling, okay? So that means the function ends at return, but then you need to call it. So How do you call it now? Guide us.
We can either use print or we just call it direct, like integer.
You can just call it. Remember, Tony just called it
integer.
integer. Okay. I'll always do what you've told me.
Integer in bracket.
In bracket.
And any number.
5. I ran it.
Yeah.
Why do you think it gave me an error? I hope nobody is typing the answer for him. Please. Please, Tony, relax. Tony, relax. Tony, relax. Hold on. Let him get it. Let him get it. Okay, this is Rolex.
Yeah.
Okay, good. So Rolex, look at your error. It says name integer is not defined. So this integer that we are using here is not known to this program. What do you think we need to use? In this function, what is your function name? Here,
Square.
what is square?
Square, yeah.
And then what is integer? The parameter, right?
Yeah.
It is the value. It is the value that is required, right?
Yeah.
So that means if you are doing a call, you call it with its name. You call it with its name. Umeona?
Yeah.
You call the name, it gives you 25. Print is the name of the function. Square is the name of the function. For Tony was num square and S is capital. That is the name, okay?
Yeah.
So I just want you to add a little thing in this. Let me see if there is another person who wants is checked. Oh, okay. Thank you, Samuel. Thank you. Somebody says, this is who? I'll read. Samuel, integer is a parameter, not a function. Parameters can't be called. Functions and methods are. Thank you. I think I love that. So now I want you to do a little modification to this program. What I want you to do is to make it so that I don't just mention this parameter. I input it. So the user needs to input a value, then call your function, then the function should work on the value that I have input. Am I understood? Let me write. Just a little modification. So the modification that we are going to have is that, I'm explaining it first. You see over here, I am putting values 5. I am putting values 5. I am putting values 3. I don't want that. I want that, of course, we have all defined our function and we have defined it in the same way. We are just using different words, but the function is already defined, so don't bother. Just come to the body of the program and allow the user to enter, to input the value to be squared. I'm going to mute somebody. I'm feeling pain, but I have to mute you. Okay. So allow the user to enter or input the value to be squared so that you don't write it. Somebody has done that already. Wow. Okay, Tony, I'll copy yours. I'll copy yours and paste. And run it, okay? That's yours. Okay. This is what I don't want. Let me show you what I don't want. This. So the moment you have it, I'm not going to run it. I don't want that for. I want that when I run this code, I will be required to input a value, and the value that I input will be squared. So as
Replace it
long
with
as
num.
this 4 is here, I'll check what you have
Replace the
next.
4 with the num. Replace the 4 with num.
I replace it with num. Okay, let me do that. I'm loyal. That way. There is a big error. Num is not defined. The program does not even know what num is. What do you think we need to do? Just check it keenly. Actually, you are not supposed to interfere with the function. The function ought to have just remained the same. Just a clue, just a clue. The editing needs to go where we were putting the value. We were putting the value in the body of this project. The function is okay. So do not touch it. Carry this. Control X. Let the function remain the way it was. Paste it here. Make sure it is not part of the function. So num equals input. There will still be a problem, but that problem is different from the other one. Enter a value 4. So the problem is that it will allow us to enter the value 4, but it will not be able to square 4. Why? You remember that? Because the input functions receives values as integers. So if we can, input function receives values as string. So there is no way we can square a string. We need to cast the input function so that the value that goes inside there is an int, is an integer. So now if we run this program, then we enter 4, then we get 16. I know where the problem still is, so I'll explain it again. But did we all see it?
Yes.
Tony, you are good. You saw where your issue was? Samuel, you're good. I have faith. I have not heard the female voices in this class. Faith, how are you? I'm talking to Faith Ann. How are you? You are muted. I haven't heard the voices of ladies. And then John, today you're very quiet. And then I'm just checking through to know that, Captain, have you talked today? Captain, unmute. I have to check.
No, I have not.
Why? That is not fair. You need to talk. Now make sure you're
Okay, I
talking.
joined late.
Oh, sorry.
I joined late, so I've been trying to catch up.
Okay. Thank you. Samuel is saying that he's really learning new. Sorry for saying running or instead of learning. Yeah, sometimes there is an air of Orion. Good. So I want us to understand something, because that is where the problem is. There is the function part. There is the function part, and then there is the normal body of the program. The normal body of the program, which is not part of the function. It is within the normal body of the program that we call the function. So if we didn't have this, I want to, if you allow me, I want to cut it. I will paste it later. If we did not have that, and we wanted to write, or maybe let me return it, then I use a new cell, right? Assuming we don't have the function, but we want to write a program that will help us square a number. That means we will have a number that is input. Those who are joining today, I'm feeling your pain because we had talked about how input function works. Enter an integer value to be squared. Okay, then I would say now the next thing is my square is assigned to num exponential 2, right? Then I will print my square. Make sure my spelling is the same. So if I run this program, it will tell me enter an integer value to be squared. So I'll enter 4, and then it will square it. So I don't have a function there, right? I don't have a function. This is a normal way. It is a simple code where I just put all the lines of code that allows me to square a number. But now, instead of saying my square is equals to num2, I want to write a function that does the squaring. So in my project or in my program, I will just be entering values and calling that function square. Then that is when I will come up with this. Why did I cut? I needed to, it is Control C to copy. Control C, I think.
Control C is copy. Yeah.
Yes. So then when I do this, then I make a module. I come up with a module that will allow me to square. So that part is just the function part, the square part. So that means instead of me to say my square equals num exponential 2, I will just call the square function. So the whole of this will just be a call. And you know, square is a very small thing. It could be a very large code that I am doing so many things, but then square is a very small one. So when I come down here, it is like I am in this other part of the program where there are no functions, so that I write a program that will call square, so that I can say square, I am calling square, and then I give it a value to square. When I give it a value to square and run it, it gives me 4. So instead of all this code, I just wrote this. I just wrote this. That means I just called this square. And I can call it anywhere. Let me go to a new cell. Let me go to a new cell and say square 5 and run it. I get 25. So you see, this is not even part of this cell, but I can still call my square. It will be seen and it will work. So it is reusable. I can reuse it wherever I want. So much so that if there is a problem, I will just, if I have another square that maybe squares for me 6, if I have an issue, maybe I don't want it to be squared, I just want it to be multiplied by 2, then this is the only part that I debug. This is the only part that I debug. And then when I run it, of course, this is 2 multiplied by 2. And then this now becomes 10. And then this now becomes 12. So you see the reusability is that I just come and change. I come and change these. If I want to debug it so that it adds, instead of multiplying, it adds 2 to the value that I put, then I run it, it gives me 4 because I'm adding 2 to 2. If I run this, I get 7. If I run this, I get 8. So the reusability, the decomposition, the abstraction, it is clear, it is seen. So that's why we are saying, once you define a function, you can call it several times and it will work. And then if there is an issue, then I don't have to come into this code change, because if I was to do that here, then another cell, then I'll be changing. I'll be saying, this part it was adding, then this part it is supposed to do this. But with this, I just change it once, and then the debugging is done. I am able to do it. It is just like pop, it does it for everything else. So if that part is understood, then assuming that I am in this cell, but I want not to have the value, the parameter value like that. I want somebody to insert or to enter. Then what I need to do is maybe to define a variable x, which will be an integer. So for those who don't know concat, I can say input, enter the value x as an integer. What this will do, if I run it, it will give me a space to enter the value integer, the value 4. But this 4 is a string, because input function, this input function, it accepts all the values that are input as a string. It doesn't see float, it doesn't see integer, it only sees string. But because I want to square the value that I'm entering, then there is no way I can square a string. I need to change it. So maybe I can come down here and say int x. So that will make it int. But I love putting it here so that I say any value that I input should go in as an integer. So then if I run it, then that number 4 will be an integer. Of course, you know, this is just to allow me enter value 4. But because I want to square it by the use of this, function, let me run it to be captured. By the use of this function, then I need to say that square. So I call the square. I call this here. I am calling it. Okay. So when I call it, it will be, its work is to multiply the number that I give it by itself, or to give an exponential. This is what it returns. When I call square, then the square will square the value that I will give it. So my work is to give it a value. And the value that I'm now giving it is that you square, I have called it exact spelling, but then in bracket, the value that I'm supposed to give it is this value that I've entered. So I give it X. I give it X. So if I run it, tells me enter value 6. Sorry, square. I think I have a spelling error. Control V. Run this cell. This cell. Yes. Did I make it better? Somebody says mine, I think, has an issue. Captain, you pasted this. Do you want us to still run it? No. After that explanation, no, right? Yeah. So Samuel, paste yours that you think has an error. Paste it in the chat. Somebody, okay, Samuel is asking, so the num parameter is overwritten. which one? Here. Where? In cell 54. Okay, this. Aha. So that actually is supposed to be our next topic, because then our next topic, we need to think of local variables and global variables. Local variables and global variables. So when we learn that, then it will help you understand why this num. Of course, I can put num here and just put it here, and then it works. And then it works. The issue is when we have a function like print, you know, we are not seeing, we don't know it because we didn't define it. So we don't even know what is inside it unless you put the question mark to see what is inside it, right? We don't know what is inside it. So whatever is inside it is hidden from us. And that is what we are calling abstraction. We don't know. So we are assuming that this code doesn't even know what is inside square. What this code knows is only that when you call the function square, it squares the value that you give it, right? So this argument here was only used so that it helps us square whatever will be given. So whatever will be given is not known to us, but what we know is that it is an integer value. The only thing we know is the name square. That is why it is only square that we are calling. This one we can call anything that we want. Can call it A. We can have it just as a number, the way we did up here. We just did 5, and then it was integer. So it is just an argument that is used to help us to know what the function will be doing. So this word integer is local to this function square. It is not seen anywhere else. So in any other part of the program, the word integer or the word num is unknown. It is a local parameter, like it is a local variable. It is only known within that function where it is defined. It is not known globally. So we don't care whatever was used. What we know is that every time we call the function square, it should return for us the square of any value that we give it. So there are local variables and there are global variables. And that is what maybe we will be seeing in our next lesson. Oh, you said, haha, you just remembered. I know you must have done C++ or C or Java, right? Yeah. And now that you have done that, now you understand when we talk of local and global. So it is not seen outside that function where it was defined. We don't know all the function, all the parameters that are inside this print. We only know that every time we print, we get to see a result. But whatever was used is not our business. We don't care. We don't know, we don't even know these things here. We don't know. What we know is that when we use print, it should be able to print for us in this manner. period. Period. Yeah, somebody says, yeah. Okay, Samuel, thank you. Good, 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 good. So I think in our next lesson that will be on Friday, we will see about, we'll still talk about functions. Then we will see about the local variables, the global variables, and we'll see a function that calls itself. We will see a number of things on Friday, but still we'll be talking on functions. So let me stop. Or any question that is relevant before I stop recording? It may help somebody who wants to record later, to listen later, to capture your question. Good. So I'll stop recording.